This is about micro-trenching and mini-trenching. Now, just to explain what that is to make it clear, micro-trenching is considered trenching that is up to 100 millimetres wide. So in this particular trial, we'll be looking at trenching at 70 mils wide. And that's the large part of what we're going to be doing in here in the next 2 or 3 weeks. Mini trenching is considered to be between 100 mils and 300 mils wide. We'll be installing a cabinet on the top of the corner. We will also install blow-in fibre to about a dozen houses. And that's blowing it from the cabinet through the ducting, coming out at the street to the boundary. That's the end of the trial. I mean, we all know what trenching does. It's a bloody mess out there, eh? It creates a habit, it creates a bit of concern, and there's always an 0800 number, and that's always hot. So I guess one thing about micro-trenching, it's fast. So maybe we're not going to be around as long as what traditional trenching would be. We're actually trenching in the road at 500 mils, so we end up with a 450 cover in the roadway, which is not the normal standard. The benefits might well be that at that particular depth, given the extensity of the rollout, there may be a lot less disruption to existing services. You can appreciate there's kilometres to be laid around the country. The ground penetrating radar, the main reason today is to understand how it works, what it does. Traditionally at the moment, if we were to go out and get services marked, it's a manual process. You basically ring up and service providers and utilities will go out there and paint red, green, blue, black and yellow all down the street. Now, from a cost point of view, it's pretty good, it's reasonably inexpensive. But the backlash, of course, is it doesn't give you depths. You need to know the depth. So what you have to do traditionally is you have to pothole. All that costs money. The Navy with micro-trenching and the GPR, it gives you a 3D sort of animation, but it gives you depths. So you know in advance that service is 250 mils deep, if you like. Traditionally, gas, power, water mains, sewer mains, they're all fairly deep. You come into issues when you get into perhaps water pipe tee-offs to tobies, they're relatively shallow. And unfortunately, probably the biggest user underground is telecommunications. So hence the reason for GPR, let's understand it, let's see what the benefits are. I guess there's a cost implication too, so we need to try to understand that.
Okay, thank you, Henri. My name is Thomas. The process really is just pushing the GPR across the ground, detect the buried asset, mark it with paint. But the fact that some of the maps are like 30, 40 years old. So we take it one step further with the mapping. We overlay our results onto existing results in AutoCAD maps. And so these are some of the screenshots from the software that we use. Each of these corresponding to one slice from a GPR. So once you slice to a depth where there is a pipe, you start seeing this red line popping out on the screen. Okay, this is a map that is one of these companies that bought our system. They actually did a mapping, and this is the original map they received from the council. And the red lines are the actual location of the pipes. As you can see, they are not very accurate. And I guess this is where, for a case of mini trenching, micro trenching, it's important to know exactly where the pipes and cables are, how they're routed, and that's where mapping is going to give you a very good overview of what's on the ground. So basically, it's just running. The GPS captures the position, and all the antennas are calculated offset from the position of the GPS. And then we export everything into AutoCAD. We get X, Y, Z, X, Y in positioning, and Z in the depth as well of the utility. So by vehicle, 15 kilometers per hour. Probably doesn't sound like a lot, but just think about it. If you do about 4 passes on the road, so 15 kilometers per hour as compared to pushing a cart, it's really, really efficient. And I think in European countries, companies bought the system, they can acquire 10 kilometers something per day. very easily because all you do is just keep driving. It's just an overview of the antenna, how it looks like. So there's 3 boxes, 3 array. The 2 orange array are the ones that detecting the main line. It's going parallel to the road basically. And the center array of antenna is for detecting connecting lines. So the main activities we try to locate using utility mapping technique. We try to facilitate the micro trenching, mini trenching on the road, footpath, and cross verge. We want to detect all utilities, especially those shallow ones for the trenching. And wanting to verify the micro trenching path as well. So it's quite easy once you have a map with all utilities in front of you to decide which is the best path to take, compared to when you go on site, you do the scans and track figure out all the pipes.
And then we collect 40 channels.
Okay, this is a screenshot of the scan that we did. This bold blue line represents the scan that we did on the Waipunamu drive.
When we're on the road, the plan is to go close to the curb, right?
Yes.
So why did you actually do the middle of the road as well?
I mean, we can do just one side, it's no problem.
We just decided to do that.
Oh, okay.
But you would just do that section.
So you must have to manage the parked cars somehow. That'd be a nuisance, wouldn't they?
Yes. There's traffic control help us with that, so it's not good. Apart from one guy who didn't move his car because it's on holiday.